Cool. So I'm Brad Malin. So I'm the Accenture Professor of Biomedical Informatics, Biostatistics, and Computer Science at Vanderbilt University, as well as the Vice Chair for Research Affairs in the Department of Biomedical Informatics at Vanderbilt University Medical Center.
I'm Deven McGraw. I'm the Chief Regulatory and Privacy Officer at Citizen Health. Before I came to Citizen, which I've now been with the company in its various iterations since the start, but before that, I was the Deputy Director for Health Information Privacy at the HHS Office for Civil Rights, so all things HIPAA.
Given you're pretty aware of the privacy-enhancing technologies landscape, and you have kind of a comprehensive knowledge of the triple-blind system itself, can you tell me some insights? Why do you think, or how do you think, or do you think such technology is suitable to enable privacy-preserving operations, being HIPAA compliant without even requiring the conventional de-identification, without physically removing PHI from the data first? Usually a lot of prospects, when we describe the technology to them, we tell them you don't have to even remove the PHI, but this is still HIPAA compliant. They're like, whoa, explain it more.
Yeah. Well, I think the benefit is that you have the ability. So as a data scientist myself, when you get to write your code and then execute that code so that you can learn your model or learn information about the population that you're potentially going to interact with in the future, it's really powerful to have an environment that gives you the ability to just press go and then learn something. I think, what a lot of organizations have done historically is that they just share the data, usually in some type of reduced level of fidelity, right? And that's what we do in de-identification, which will work for certain use cases, right? But the more fine-grained of a question and the more nuanced somebody needs to know about like general demographics, then being able to run this in a model-based setting is extremely useful. So it has a place. Now, the other really useful benefit of it is that you can ask questions over time, right? So you're not limited to like creating just like a single question and just getting an answer, right? So you could ask and refine your hypothesis as you're interacting with the data, or at least interacting with the models at that point, which is really helpful.
Yeah, I want to double down a little bit on something that Brad noted, the use of this tool by an HIE, which is continually refreshing data on a daily, if not hourly basis from its data sources, I think really increases the value proposition here, because again, this technology is sitting within the environment of the HIE that's constantly refreshing the data in the background. So if you're running the analytics and the computations on top of that, you're able to sort of continuously refresh what the results are that you're able to deliver to a customer. And again, the clinical trial use case is a super high value proposition because most HIEs are purpose-built to advance treatment interests of the patients whose data the HIE stewards. And certainly delivering to a patient's clinician a set of tools that can help them treat a patient better is a really high value proposition for an HIE. And as more and more of these HIEs begin to, consistent with the information blocking rules, help patients get their data, this is also potentially a tool that can help a patient identify a trial out that they may be eligible for outside of necessarily waiting for their clinician to provide those recommendations to them.